All right, for this lab, here is today's date. Go down here, click this, it'll take you to this document. And this is, once again, your generic write-up. So what we're studying is what happens if all you change is the pedestal height. So the height of the pedestal is what we're studying. So what you want to do is go file, make a copy, and I would put, what height, let's see, how about Canon. So you first put your name, then say dash Canon height versus distance. That'd be a great way to title this. And then we can get to work. It's height versus distance. And we want to change this to height. How does the height, and then might as well make it proper and say of a cannon. I think that'd be a little bit more helpful to whoever's reading this. Affect the distance cannonball goes. Cannon, looks like I'm getting bold, so I'm going to hit Control B. A cannonball goes. Right, so that means I can take the highlighting off of this. Click up here, say none. That means that this should be height. And this would be distance. I just say DIST. And we don't need highlighting on any of that, so I'm going to take that off too. All right, so then your graph's going to go here, and your procedure, you just say place cannon on, and I want to get rid of the highlighting again. Place cannon on pedestal at 0 meters high, and set it at let's see, I'll just pick a random angle, 45-degree angle. The angle and all the other things are going to stay the same. I should probably use a comma here. So we're going to set it at an angle and fire. Or I could say fire and record the distance in the data table. Then increase pedestal height 1 meter. And repeat. Do this for all values in the data table. So for our data table, we have to decide. You go 0 meters, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'll be good. The stuff that we need is a cannon, adjustable pedestal, measuring, and I'm writing these instructions and the materials list as if I'm actually physically doing the experiment. I'll probably need like a measuring device, measuring tape, I guess, football field, help measure distance. What else? A protractor. That's probably good. Now I want to say if I increase the angle, we don't want that bolding and we don't want the highlighting. The angle, no, the pedestal height of a cannon Oh, actually, I want height. Height is the operative word. So I'm going to move this of a cannon to the other side of a cannon. I want to get rid of all that highlighting, so I might as well do it for the whole paragraph. Boom. All right. Get rid of the bolding. If I increase the pedestal height, then the distance the cannonball goes will increase. I'll say linearly, right? Because firing from a greater height will enable the ball to travel further. Okay, and once again, let me get rid of the bolding, and this independent variable is height, and the dependent variable is distance. Okay, so for constants, we want to keep everything constant, like the size. Use the same cannonball at all times. Get rid of the bolding. Use the same cannonball every time. Make sure the wind is still or the same every time. Keep the angle the same for all trials. What else should we keep the same? Same amount of gunpowder, I guess. Powder every time, etc. The only thing that should change is the pedestal height. So as far as the conclusion, you're going to say whether it supported your hypothesis. So, in the end, you might say the data supported my hypothesis. Whoops. Get rid of everything. Let's pretend that this is the actual answer, because we don't know until we actually do the experiment. The data supported my hypothesis. As I increase the angle, the cannonball traveled a greater distance. But I might find out, but it seemed to decrease slowly each time. In other words, I already did the experiment. I saw that the cannonball did go further each time, but it seemed the distance that it went got incrementally smaller every time. Now, for sources of error, you want to say, pretend you actually did this, and you'd say something like, I tried to find a day when this example that I gave last time works well because we're doing the same type of simulation. The wind might have been blowing. These sources of error are things that got into the experiment that you didn't want to get in there. So we're just pretending, because obviously this is a simulation, and in the simulation you have near perfect, environmental factors. So anyways, there was a small breeze on the day. Let's say the football field was pretty level, but had a few uneven spots. Yeah. So there you go. All you need to do now is fill in this data table. And let me do a quick example of how this would work. Set the pedestal at 0, and let's go 45 degrees and just fire. And then measure the distance by using this right here. Or maybe this would be better. Yeah, this is pretty accurate. So we fired, and it went, the range was 4.95 meters. So let's put 4.59. Whoops. 4.59 meters. Then we go to the next one, increase it 1 meter and fire. Then we use our little range finder thing, 5.85, 5.85, and then we just keep going. That's how you do this lab. Good luck.